Welcome back to Through Inquisitive Kids. In this video, we will be talking about nonlinear relationships. Our course outline for this chapter is very short. We are already halfway through our entire chapter. In this lesson, we're going to be talking about nonlinear relationships. Our learning goals for today is to understand the relationship between variables in nonlinear relationships and understand the information shown in a nonlinear relationship. Recruitment notice. Dear students, the school radio station wants to recruit a weather presenter. The following questions are designed to test the basic skills of students. Please submit your report to the school radio station by the end of this week. Everyone is welcome to participate. I wish you luck on becoming the host of our school's weather presenter. It's actually not the host, it's just I wish you luck on becoming our school's weather presenter. So this seems like it's a recruitment notice to this school radio station club or a school radio station. And as you can see here, we have sunny, partly cloudy, moderate rain, showers, and so on. And we have to work on our basic skills in order to become a weather presenter. The following table shows the temperatures at each time of a certain day. I want you to analyze the changes in temperature on this certain day. We're going to say that this is the 0th hour, let's say 12 a.m. The temperature is 26 degrees. We don't know if we're talking about Fahrenheit or Celsius. And in the 3rd hour, let's say 3 a.m., the temperature is 23 degrees. And then so on. And if you want to graph this out on a graph, you would be left with this diagram. The x-axis is our time, or hour, and the temperature is on our y-axis. And this line that's going up and down here is the temperature. So the graph shows the change of temperature with time. It shows the relationship between temperature and time. This is another way for us to express the relationship between variables. As you can see, it can be very straightforward and visual. You can see how the temperature is changing. It first dips down a bit and then goes up and then goes back down. Answer the questions and fill in the blanks according to the graph. Number 1. The temperature at 9 o'clock a.m. is blank. And what about the temperature at 12 o'clock? So here, we're going to look at our graph. We're going to call this point M. So point M is at 9 a.m. and the temperature, the corresponding temperature is 27 degrees. And at 12 at noon, the temperature is 31 degrees. So our answers would be 27 degrees Celsius, I guess we're talking about Celsius, and 31 degrees Celsius. Number 2. The highest temperature on this day is blank, and it is reached after how many hours? What is the lowest temperature on this day? As you can see, the highest temperature on this day would be this very top point, point D. That's 37 degrees. And it is reached when you look down, so see what is the x coordinate of point D. You can see that it is reached after 15 hours. And the lowest temperature would be at point E, 23 degrees Celsius. Number 3. The range in temperature on this day is blank, and it takes blank hours to get from the lowest temperature to the highest temperature. So what is the range in temperature? Well, all you have to do is subtract the lowest temperature from the highest temperature. You get 14 degrees Celsius because 37 minus 23 equals 14. And in order to get from the lowest temperature to the highest temperature, it takes 12 hours. 15 minus 3 equals 12. In what interval does the temperature increase? In what interval does the temperature decrease? So first of all, what is an interval? Well, it's kind of like a time period in this case. So between which hours did the temperature increase and between which hours did the temperature decrease? Here we have point E, that's the lowest point. And from point E to point D, as you can see, the temperature is increasing. When you look at the x-axis coordinates of both of these points, you can see we are left with 3 and 15. So when it is increasing, it is from the 3rd hour to the 15th hour. And this decreases from B to E and from D to F. There are 2 intervals where the temperature decreases. So our answer would be from the 0th hour to the 3rd hour and from the 15th hour to the 24th hour. Number 5. What does point A represent on the graph? What about point B? Here, as you can see, we have point A, and this is point B. Well, point A is referring to the temperature at the 21st hour. Point B is referring to the temperature at the 0th hour. Number 6. Can you predict what the temperature will be at 1 a.m. the next day? Explain your reasoning. So at 1 p.m. the next day, it would probably about 24 degrees Celsius based off of what we already have here on the graph. Here we're going from 0 to 3, so this would be approximately the 1st hour. Based off of what we already know, our best prediction would be about 24 degrees Celsius. Conclusion. When we are using a graph to represent the relationship between two variables, the horizontal axis, called the x-axis, usually represents the independent variable, and the vertical axis, usually called the y-axis, represents the dependent variable. When we go back to the previous slide, our time is the independent variable, and our temperature is our dependent variable. It changes along the time. Here's some more practice. As shown in the figure, the temperature of a certain city in summer changes over time. Which of the following statements are wrong? Remember, this is asking for which of the statements are wrong. Let's look at number A. The highest temperature at 15 o'clock today. So the 15th hour indeed is the highest temperature, so that is actually correct. The lowest temperature is at 3 o'clock. Yep, that is true. Doesn't mean that it's our answer. The difference between the highest temperature and the lowest temperature today is 13 degrees Celsius. So the highest temperature would be 38 minus the lowest temperature, 22. When we subtract that, we get 16, which means that this is wrong. Let's still look at letter D. The temperature is dropping from 0 to 3 o'clock and from 15 to 24 o'clock on this day. So 15 to 24 and 0 to 3. That's correct, which means our answer would be C. The graph below shows a change of water depth at a port from 12 o'clock p.m. to 6 o'clock p.m. on a certain day. At about what time was the water the deepest? How deep was the water? What does point 8 represent? And what was the changing trend of the water level from 12 p.m. to 6 p.m.? Based off of the graph, we can see that the water was deepest at 3 o'clock p.m. about this time, and it was 7 meters deep. Point A represents the depth of the water at the 4th hour, or at 4 p.m. And for question number 3, the changing trend from 12 p.m., this would be basically 12 p.m., and to 6 p.m. would be first increasing, then decreasing. You can see that we are increasing from the 0th hour to the 3rd hour, and then starting to decrease after the 3rd hour. A camel is actually nicknamed the strip of the desert. Its body temperature changes greatly over time. Here is a nonlinear graph showing its body temperature. And you can think of the 25th hour as the 1st hour of the next day. What is the range of a camel's body temperature in a day? How long does it take for its body temperature to rise from its lowest point to its highest point? So in order to find the range of a camel's body temperature, you first have to find the highest body temperature. As you can see, in this case, it would be 40. And then its lowest body temperature would be 35. That's right in between 36 and 34. So then you subtract that, and its range would be from 35 degrees Celsius to 40 degrees Celsius, or you can say a range of 5 degrees. And it takes a total of 12 hours in order to get from its lowest point to its highest point. You can see that by looking at the lowest point, that's at the 4th hour, and the highest point is reached at the 16th hour. 16 minus 4 equals 12. How much did the camel's body temperature drop from 6 o'clock to 24 o'clock? Over what interval did the camel's body temperature increase? Over what interval did the camel's body temperature drop? And what is the relationship between the camel's body temperature at 8 o'clock the second day and 8 o'clock the first day? I want you to pause the video and go back to the previous slide to look at the nonlinear relationship graph. So from 16 o'clock to 24 o'clock, it dropped by 3 degrees Celsius. I guess we're using the military time. And for the third question, our answer would be, it's increasing from the 4th hour to the 16th hour and from the 28th hour to the 40th hour. It's decreasing from the 0th hour to the 4th hour, from the 16th hour to the 28th hour, and from the 40th hour to the 48th hour. What is the relationship between the camel's body temperature at 8 o'clock the second day and 8 o'clock the first day? So 8 o'clock the first day would be this point. 8 o'clock the second day, you have to add 24 to it. That's 32. As you can see, they are at the same y-axis, so it's the same body temperature. This is our last question. What does point A represent? What other times have the same temperatures as point A? Well, point A represents the camel's body temperature at 12 o'clock. And some other times that have the same temperature as point A would be the 36th hour and, the 20th hour and the 44th hour. Class summary. Today we learned about nonlinear relationships and graphs. So in our previous 2 lessons we've talked about tables and equations. So far the equations we've learned are actually linear relationships, which means that when you graph it out, it's a straight line. But in this lesson we talked about curving lines. And as you can see, this was a very visual way of presenting mathematical information. Based off of observing a nonlinear relationship, you can find the changing trend of the data, and you can look at different intervals and see if the values are increasing or decreasing. So I hope you learned something valuable from this video, and be sure to come back for the last lesson of this chapter.